Hey guys, it's Nick from WGuru.com. Today we're going to be talking about electric power. So before we talk about electric power, I think it's important to review what power actually is. So we need to go over three things: work, energy, and power. So there's a relationship between work and energy that we need to go over first. Simply put, energy is the ability to do work. So let's do a thought experiment. Let's say you have a ladder, and you are standing at the bottom of the ladder, and you weigh 500 newtons. I don't know how much you weigh. I don't even really know how many pounds 500 newton is. I just made it up, so don't get offended. So we define work as a force times a distance. So in this case, we have our force, 500 newtons, and we have a distance of 10 meters. So if we were to climb up this ladder, we would multiply 500 newtons times 10 meters, and we would get the work required to get to the top of the ladder. And that ends up being 5,000 joules. So if we did 5,000 joules of work, that means that at the top of the ladder, we end up with 5,000 joules of energy. So we did work on the system, and we ended up with energy in the system. So what about speed? Let's say we climbed this ladder in 10 seconds, and it took us so much power. What would happen if we had to climb this ladder in 1 second? Would it be more difficult or less difficult to do it? Personally, I wouldn't want to climb a 10-meter ladder in 1 second. That would be really difficult. So the relationship between energy and power is time. So we define power as energy over time. And we measure this in watts, which is in joules per second. And this is what we came up with earlier. If we decrease the amount of time that we climb up the ladder and keeping the energy the same, the work we do on the system doesn't change, but we decrease the time we have to do it, it takes a lot more power. It's a lot more difficult for us to get up the ladder. Whereas if we have more time, then our power goes down. It's not as hard to do it if we have more time. So let's do some numerical examples. So this right here is a little LED. Excuse my drawing, it's really bad. And this is our battery. So in this example, current will flow through the wire, and we'll end up with some light energy going out. So let's say we have 10 joules of energy leaving this battery, or this light. Now, of this 10 joules of energy, we're going to look at what would happen if we released all of the energy in 1 second, and what would happen if we released all of the energy in 10 seconds. How much power would that take? So if we look at the units on power, we can take this 10 joules over 1 second and see how much power that's going to be. So we end up with 10 watts for that one, and let's do it for 10 seconds. We end up with 1 watt for that. So we can see that if we increase the amount of time that we have, the power goes down. And it's interesting to note that this difference in power here we perceive as brightness. So how do we quantify this in electrical? So the way that we do it is we take our current and our voltage measurements. So we can see that if we multiply I and V together, our coulomb should cancel, and we should be left with joules per second. So that's what we get right there. So that's how we come up with this. So power is equal to I times V. Power is equal to the current times the voltage. So we can take this a little further. Let's start out with our power law. And we also know that current is V over R, and we know that our voltage is equal to I over R. So if we plug these guys into our power equation, we get something else out. So these are two that you're also going to want to remember, guys. The good thing about these two is that for this one here, you don't need current to solve for power. Notice that the current dropped out. And over here, you don't need the voltage to solve for power. The voltage dropped out. So if you only have two of the things that you would normally need to solve for Ohm's law, you can use those two to solve for power using any of our three equations. So these are your takeaways, guys. Put them on your reference sheet. That's all I got for you today. Good luck on your exams.